Hey everybody, this is Larry. This is day. Oh, yeah, it's the last day. Well, if you made it this far, congratulations. 1 month down, 12 more to. Man, off by 1 hour, am I right? 11 more to go for the end of the year. Wow. But hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm. It is last day of the month here. It is -17 here Celsius, so 0 degree ish Fahrenheit in New York City, and I just came back from a run, and I only went for like a 30-minute run, and I was just like sitting doing nothing for like an hour because I was just like tired and dead and all these things because it's just so cold. But now I'm a little bit warmed up. I can do an easy problem hopefully. Already had an off by one today, right? So we'll see. Today we have 744. Find smallest letter greater than target. You're given an array of characters, letters that are sorted in non-decreasing order, and a character target. There are at least 2 different characters in letters. Return the smallest character in letters that is lexicographically greater than target. If such a character does not exist, return the first character in letters. I mean, that seems pretty straightforward, right? I mean, it is easy after all. I mean, it is non-decreasing, so it's already sorted. So, yeah. And this gives you a practice to on some library as well, because I think a lot of people get confused about bisect left and bisect right. Maybe not. That's whether that's you or not. Maybe not. But yeah. So then here for letters, we want to search for target, and this will give me the next character, or the technically, or more strictly speaking, I think the language is that it will give you the index in which when you insert this character, or the character, I guess it's not that precisely, but I have to do it that way. But it's the index in which when you insert it, will be strictly greater than the index before, right? Or the first character, I suppose. But yeah, so this will give you the index, right? So index is equal to this. If index is greater than length of letters, that means that you're inserting at the back, and that means that, well, there's no letters after it. So then you just return the first letter, right? Or the first whatever. Otherwise, then we return letters and we are good, or index of letters. Hopefully we're good. Otherwise, I'm just like, man, I didn't even do the easy way. Let me just double check that there's no silly mistakes, but should be okay, I think. Yeah. Yeah, wow. I mean, yeah, this is fine. It's binary search. I'm curious what beats it. Is there an over one thing? I mean, I guess you could. No, but I was gonna say maybe you could do a set and then look it up. And I know maybe this in Python certain things are faster, even though complexity-wise they're they're of higher complexity, but the constants are lower, right? And I could see, if you put everything in a set and then you just do a for loop of 26 items or something, maybe that'd better. I don't know. Than binary search. And one thing that I would say though, right, is that and it doesn't come up that much, but I'm just going to talk about it because why not? I mean, this is an easy problem and we're basically done. Is that one downside about binary search is that it is not memory. I mean, it's not great memory wise, right? In the sense that you're always jumping from a random block to a random block, effectively random, and more importantly, almost by definition, they're not in the same block, and that's your search radius or your search has gotten to a point where it fits in one block, right? And what I mean is that you lose a lot of locality because you're jumping from block to block. You have to read things from cache, and every time it's a cache miss because, like I said, it's going to jump back and forth, right? Where maybe if you have a for loop, right, it is very parallelizable, and then you could do like branch prediction and stuff like that, and each block would be loaded in memory in a very efficient way. I mean, I'm not going to say that's the reason why, because at a certain point, this is like, what, 3 millisecond? I always keep saying micro. I was much slower last time anyway. Oh, I guess I could have done that too. That's cute. But I mean, obviously slower, but cute. But yeah, I mean, I'm not saying that's the difference because at a certain point it doesn't really matter. But these are things that you can think about when it comes to, I don't know. But I say computers are so fast these days because I think back in the day, these are things that people think about. And if you're doing some sort of embedded system or something like that, maybe it's still an issue. But you know, even my phone has like gigs of RAM. I was gonna say cache, but I mean technically, but even my phone has gigs of RAM these days, right? And the RAM is like super fast. So I don't know. But that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to good mental health. Oh yeah, before I finish though, because I kind of left, or I didn't finish what I was gonna say. I did, but then now I think of one more, which is that I just say all that stuff for fun about like memory and all these things, so that maybe if you are interested, do a Google, do a YouTube, whatever, search for it. But I was gonna say is that now I forgot. Huh. What was I gonna say? That's what happens. I'm a dumb man. Wow. Oh yeah, but what I was gonna say is that all these things are just hypotheses, right? Like if and also all these things are possibly premature optimizations, right? You don't need to optimize before you have to. This is clearly fast enough. Even if follow-up is fast enough, then you don't have to optimize, right? But if you have to optimize, if you find that it is the choke point, this is what benchmarking is for. You don't have to guess. I mean, complexity analysis is nice, and for big ends, it'll probably win, but constants do matter in real life, and this is where benchmarking comes into play. And you'll find that maybe certain things have get constrained by I/O, so it doesn't even matter because you can load the entire array in memory, and in memory, then I/O is not a big issue. Though nowadays, SSDs may be faster anyway, and even SSD has a cache on the I/O side, right? So I don't know. There are a lot of considerations, and these are the things that, as you get better and as you read more books or whatever. Maybe people don't read books anymore, but I don't know. Watch more YouTube, whatever the equivalent it is for kids. You get more familiar, and you'll get the play of it. Anyway, this is a long video for a silly problem. Hopefully, you find it slightly interesting. That's all I have for today, though. Let me know what you think. Thanks for watching. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye-bye.